Come with us on a journey through an ancient land where vibrant greenery and sweet scents fill the air. But amidst this beauty, there's an unsettling quiet, a sign that something isn't right. The once lively chatter of birds and animals has faded, hinting at the danger posed by a changing climate. As the grip of an ancient era weakens, the waters rise, swallowing the lush landscapes below. Soon, what thrives here will be lost beneath the vast expanse of the Pacific Ocean. In the midst of this unfolding crisis, important questions arise. What caused this peril? What can we learn from history hidden deep within the icy heart of the polar regions? These are urgent questions that demand our attention, for the lessons of the past echo loudly in our present reality. To know more about it, stay with us till the end of this video, and subscribe to our channel for a steady flow of interesting content. Gaze up at the night sky, and you'll spot Andromeda, our nearest galaxy, a staggering 2.5 million light-years away. Despite its vastness, it's still within our reach. Yet, it's curious how we struggle to connect with something as near as our own future, just 80 years away. Understanding that our actions today shape tomorrow's world can feel distant. But let's bridge that gap together. Our journey begins with ice, a remarkable substance with immense energy storing capabilities. To put it into perspective, the energy stored in the ice could barely melt if packed into the back seats of a modern electric car, despite its power to propel tons of metal at high speeds for long distances. This ice, crucially, acts as a buffer against drastic temperature changes, maintaining stability in our climate for the past 12,000 years, a period known as the Holocene. It's during this time that human civilizations flourished, thanks to stable conditions facilitated by the ice caps, Antarctic and Arctic, that formed millions of years ago. These caps, crucial for our planet's stable climate, have been influenced by Earth's position and tilt in the solar system, known as Milankovitch cycles. The cycles predict that ice at the poles should be growing, hinting at an impending ice age, and as a result, sea levels should be dropping with deeper ice caps. However, reality paints a different picture. The polar ice is melting, absorbing vast amounts of energy, and the loss of ice is speeding up. If all the ice were to vanish, we'd face a staggering 70 meters rise in sea levels, submerging coastal cities worldwide. Though such extreme ice loss is improbable, it's crucial to gauge potential sea level rise for future planning and safeguarding Earth's ecosystems. To make these predictions, we must unravel the mysteries behind the ice's meltdown. We know that the surge in greenhouse gases is driving today's global warming, overpowering the natural cycles and causing ice caps to melt, thus elevating sea levels. However, what surprised me was learning that this wasn't always the case. Deep within Antarctic ice cores lies a historical record revealing that rising temperatures once triggered increases in CO2 levels, a reversal of cause and effect. This may seem contradictory at first glance, but in reality, it's a symbiotic relationship. Rising temperatures thaw permafrost in the Arctic, releasing stored carbon, which in turn intensifies global warming. The intricate interplay between rising CO2 levels, temperature, and the polar regions unveils the complexities of our climate system. Greenhouse gases, such as CO2, act like a blanket, trapping heat radiating from Earth's surface, an essential process for maintaining a habitable temperature. However, excessive accumulation of these gases disrupts this delicate balance, leading to a warming planet. Understanding how these gases interact with temperature variations is crucial for deciphering the mechanisms behind polar ice melt and its repercussions on global sea levels. The atmosphere holds about 5.5 quadrillion tons of heat, while the ocean contains a whopping 1.34 quintillion tons. Surprisingly, the ocean absorbs around 90% of the extra heat, which isn't shocking considering it's almost 250 times heavier than the atmosphere. So where does all this extra heat go? Well, just like how touching a hot stove burns your fingers, heat naturally flows from hotter areas to colder ones. That's why we see a significant increase in temperature at the cold poles. It's where the energy naturally travels due to the temperature difference. Most of this energy travels through ocean currents because water, being denser and having a high heat capacity, is excellent at transferring energy. This property of water is why it's used as both a coolant in cars and a heat source in homes, while air, with its lower density and heat capacity, is better suited as an insulator. This difference explains why you can endure a 90-degree C sauna but would struggle to withstand water of the same temperature. The melting of ice, influenced by factors like the albedo effect and the presence of soot, reflects a complex interplay of natural processes and human activities. Albedo, often described as the whiteness of surfaces like ice, plays a crucial role in regulating Earth's temperature. When ice is covered in dark soot particles, its albedo decreases, meaning it absorbs more sunlight and heats up faster. This phenomenon accelerates the melting process, contributing to the loss of ice cover in polar regions and mountain glaciers worldwide. Efforts to combat air pollution and improve air quality have been shown to have a positive impact on reducing the deposition of particulates on ice surfaces. By decreasing the amount of soot and other pollutants in the atmosphere, we can mitigate the darkening effect on ice and slow down its melting rate. However, this solution comes with its own set of challenges. Reducing atmospheric particulates also means allowing more sunlight to penetrate the atmosphere, potentially intensifying the greenhouse effect and leading to further warming of the planet's surface. Beyond the scientific implications of ice melting, there lies a broader narrative of resilience and adaptation. Throughout Earth's history, diverse cultures and species have evolved in response to changing environments. From the depths of prehistory to the modern era, humanity has demonstrated remarkable ingenuity and adaptability in the face of environmental challenges. Our ability to learn from the past and innovate for the future offers a glimmer of hope amidst the sobering reality of climate change. The melting ice serves as a poignant symbol of the environmental consequences of human activities since the Industrial Revolution. However, it also serves as a rallying cry for collective action and positive change. Recognizing the interconnectedness of human society and the natural world, we are called to confront the challenges posed by climate change with courage and determination. By embracing sustainable practices and fostering a deeper appreciation for the planet we call home, we can forge a path towards a more resilient and harmonious future. In conclusion, the melting of ice represents both a pressing environmental crisis and an opportunity for transformative change. By addressing the root causes of ice loss and adopting holistic approaches to environmental stewardship, we can safeguard the health of our planet for future generations. It is up to us to heed the lessons of the melting ice and embark on a collective journey towards a more sustainable and equitable future. What are your thoughts about this? Let us know in the comments section below. Like, share, and subscribe to our channel for more intriguing and thought-provoking content like this.